All right, great. Hey, listen, welcome back. Thank you for joining us today. In attendance, we got Marcus. Marcus, go ahead and raise your hand. And Celeste, everybody, go ahead and raise your hand. All right, good. Hey, let me go ahead. Now, today, we're going to go and actually, one thing I love about today is that we're going to talk about the subject that we touched on a little bit last time. And I'm going to, Celeste, watch, go ahead and read what it says here, where it says 1-4.
1 measures of variability.
Yes. Marcus, go ahead and read the bottom.
Analyze numerical data using measures of variability, range, interquartile range or IQR, and standard deviation in order to make inferences with normal, distributions?
Yeah, let me go ahead and see if I could zoom in a little bit more for us. There you go. Does it look better?
Mm-hmm.
Okay, good. Oh, with normal, okay, so you finished. All right, and you might be wondering, you're like, hey, Mr. Sandoval, when did we cover this? When did we ever go through this? Do you remember that when we were looking at graphs, we went through one of the graphs called the box and whisker plot? Yeah, and one thing that I loved about this graph, and let me go ahead and show you, it's this one right here, the one on the left. The thing that I loved about this graph, the thing that it brought the biggest benefit is that when you're dealing with something, you like, let's say purchasing a car, you don't want to know what was the maximum that somebody paid. Like you see where everything you see over here, see how it says max? You don't want to see the max. You don't want to hear, oh yeah, somebody paid a ridiculous amount of money. It really doesn't help you, right? Or you really don't want to know what the lowest was because that really doesn't help you either. The thing that you want to know is you want to know kind of like what the middle is, right? And then from there, you want to know range. Okay, so it's okay if I pay this much more from that middle or this much this way. Because you got to discover and remember that each car is unique. Each car has its own quality, its own mileage, its own like options. Some come with leather, some with cloth seats, some come with nice wheels, others do not. Some of them been treated better. So does it make sense to you kids what I'm talking about?
Mm-hmm.
That sometimes you don't want to know you want to know this part right here. And this is what they call the interquartile range. Okay, so we're going to get back into that. But you notice how I skipped a couple of slides? So let me go back so our readers and our viewers at home can go back and take notes on this part. Let me go ahead and have Celeste, go ahead and read this.
Measures of variability spread. When examining a data set, it can be helpful to create a visual representation to aid in understanding. It is also helpful to understand how much the values are spread out. Knowing how spread out the can help you determine whether data values are very similar or very different. Values that tell you how spread out the data is are called measures of spread. Some examples of these would be IQR, variance and standard deviation.
Yeah, IQR, interquartile range, variance, and standard deviation. Now, basically what they're trying to say in a few words is this, is that you have something, okay, so like this right here, they call this the interquartile range. So let me go ahead and write that down for you. Actually, everybody at home, the interquartile. And the reason why they call it the interquartile, hey kids, what is a quart?
Four.
A fourth, right? Yeah,
Mm-hmm.
so they break this up into fourths. This is a first fourth, second fourth, third fourth, and fourth fourth, right? You notice that? Okay. And inside this quartile range, one of the benefits that you get by designing it is it also gives you the standard deviation. That's what this part right here is also known as the standard deviation. Like how much does it go up this way and that way? Okay, because it doesn't always go evenly. sometimes the interquartile range, and you'll see some examples. This line is right in the middle. And then also notice this. Notice how this says 25%. What's 25 times 4?
100.
Yeah, 100, right? Yeah, so one of the things that it does is that it seeks out the median and then gives you 50% on either side, 25% this way and 25% the other. So it gives you a good. So this is the reason why there's a first quartile. This is the median. And then that's the reason why they call this Q1, Q2, Q3, that kind of thing. Okay, so this is where it gets its names kind of. Okay, so to how to make one. Marcus, go ahead and read what it says right here, how.
To create a box plot, first find the minimum, maximum, first quartile, median, and third quartile of the dataset. Then draw a rectangle starting at the first quartile and ending at the third quartile. This represents the middle 50% of the data. Draw a line from the top to the bottom of the box to represent the median. Then draw whiskers from the end of the rectangle to the minimum and maximum data values.
Okay, so basically in a few words, Marcus, what you said right now is put all your data in a graph, like here. Like, let me give you, let me erase this and let me kind of give you an idea. What you said in a few words, let's say that in your minimum data set, why don't we talk about hours at spending at school, right? We kind of talked a little bit about this. Let's say that the minimum person spent 10 and then the maximum person spent 60, right?
Mhm.
And you remember that in the medium, it was like 32.5. And then there was like a 5. So this one went to 27.5. It was about 5. Yeah, it's 5. So 27.5. And then this went up to 37.5. Okay. So there was a 5-hour spread. But I was able to, like, if somebody told me, well, what's the average student spending in school? I'm not going to say 10 or 60, or not even average, but like, what's a range? I would tell them, oh, well, they're spending about 27 hours to about 37 and a half. So that's exactly what, but in order to find this, you go ahead and you break up things in fourths. That means that there was, depending on the number of kids, like let's say there was, let's just make it easy. Let's go ahead and put 20 kids. Then there was 5 kids, 1 here, 2 here, 3 here, 4 here, 5 here. And then another 5 here. 1, 2, 3, 4, 5, another 5 here. 1, 2, 3, 4, 5, and then another 5 here. 1, 2, 3, 4, 5. So this is how you will lay out the data, and this is how you're able to find out each of these points. Okay. Let's go ahead and move on. This is one thing that's very important. So let's go ahead and read what it says here.
How to find a 5-number summary for box plot.
Okay.
Number 1, find the median. Order the data from least to greatest and find the median middle number. Number 2, quartiles. Q1 is median of data to left of the original median. Q2 is median of data to the right of the original median. Number 3, min/max. The min is the smallest data point. The max is the largest.
Yes. So in very short terms, the reason why the 5-number summary is so important is because you notice this graph right here. Once you get familiar, like once you discover, once you know, have the benefit of knowing the box and whisker plot, this is the first number, second number, third number, fourth number, 5th number. Understand? So from there, once you understand it, you get the, you say, oh yeah, that's a median, so it's going from here to here, or this is the max. So it gives you like the fine numbers right away where to put things at. So as a result, this is what you get. Okay, so let's move on to the next one. All right. Marcus, why don't you go ahead and read this one?
Gregor is growing pea plants. He records the height of the plants. The heights of 10 plants in centimeters. After they each have been growing for 2 months is recorded in the following table. Create a box plot to display the data.
Okay, so does everybody see the table? So Marcus, what's the first thing you have to do?
First, I have to find the minimum and maximum. Right?
Yeah, you find the minimum maximum, but actually you also need to order the data. So you notice how we order the data right here?
Okay.
So they went from 19 to 24. So this was the minimum right here,
Mm-hmm.
and this is the max. Everybody knows that? So that's the reason why the max is 45, and the min on the table is 19. Correct?
Mm-hmm.
See that? Okay, good. Now, let's go ahead and count how many they are. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10, right? So the medium should be number 5. 1, 2, 3, 5. Okay, so the medium should be 30. Did you notice how this is the median?
Mm-hmm.
Okay. So once you get to 30, to go ahead and actually find, okay, so now you're gonna go, this being the min, and this being, so it's like, hold on, let me change color. So you won't get confused with all the purple. All right, so the 19, right? Now to find this part right here, this Q1, that's for the next one, right? This is gonna be the middle of the median and the minimum, right? So this being the min, notice how the middle is 26 between these two, correct?
Mm-hmm.
All right, so that's the reason why that's Q1. And we do the same thing on the other side. On the other side, we go ahead and we find out what the middle is between these two. And notice how the middle is right here. So the middle, that's how do you know that? Between the median to the other side, that's 32. So this one was 26, this one was 32, and then the middle was 30. So it gives you kind of like a real life example how to build one. Now the thing that's really interesting is this. Notice how this spread is much smaller, but it can still contains the 5 number, or not necessarily the 5 numbers, but the same amount of numbers through there. Okay, so that's the reason why you have this. So it just gives you like how much is actually changing. So like in this case, there's more uniformity between, in 30 to 32 is not much, right? So it gives you that it's more in there. That's more people are purchasing on the high side. On the low side, there was more from the medium this way. There's more of a spread than it is from this side. So that's the same thing you should expect. So if somebody shows up and says, you know what, I want you to buy something here or do something here money-wise, you say, no, that's way too off. It's off. And it doesn't make sense. It's like, it's kind of like, you know, you're going way off of what everybody else is charging, right?
Mm-hmm.
All right, good. So now let's go ahead and move on to the next one. And let's see, Celeste. Oh, Celeste lost. We lost Celeste. Okay. Marcus, go ahead and see, can you do a 5-number summary of this?
5-number summary?
Yeah.
Okay. So 25 is the minimum. The maximum would be 38. So there's 1, 2, 3, 4,
Yeah.
5, 6, 7, 8, 9. There's 10 numbers in here.
Yeah.
So 1, 2, 3, 4, 5. The 2 middle numbers would be 30 and 34, and the average of that would be 32. So the median is 32.
Okay.
First quartile would be 29.
Mm-hmm.
And then the second quartile would be 35, right?
Yeah, very good. All right, good. Now let's go ahead and choose a response. So it says find the median of the graph below. So what would your kid say? Which one would it be?
Oh, the median?
Yeah.
That would be 6, right?
Yes. Yes. Because it's right here. Let me use a highlight. Because of this line. Let's say another median. Good.
The middle line.
Yeah. And it says which shows the correct 5 numbers summary set. So what would your kid say? Which one should I pick? The one on the left or the one on the right?
The one on the left.
Yeah. The one on the left. Hold on. Mark that. And I automatically looked at it because I saw 2 and 2 is here. And then when I saw the minimum and saw 4, I knew it was off. And also the median was 6. So you notice how it all matches up. 6, 4, 9, 2, 12. You're right. Okay. Okay. Let's see. Celeste, go ahead and read this.
IQR. The IQR describes the middle 50% of values when ordered from lowest to highest. It's another form for measure of spread because it allows us to know how far apart all of our data points are.
Okay. Good. So we've been talking a lot about this because anytime anybody gives you a quote for something, like let's say a home repair or something they're going to come do for you, you just want to be within the range. This is the interquartile right here. I, Q, R. This right here. You just want them to be inside the range. And if you know it's somebody that's good and they're going to do a good job for you, well, sometimes you're okay about paying over here. Does it make sense? Sometimes it's worth the money to pay somebody to do something a little bit better than being dissatisfied because you decided to pay somebody less. So that's where your measure of where you need to make a choice on certain things, because everything's variables. I would love to tell you that everybody does the same job, but they don't always do it. Not everybody works the same. So that's the same thing. That's the same concept in this case. All right, now let's go ahead and all right, Marcus, why don't you go ahead and read this up?
Range and interquartile range both measure the spread in a data set. Looking at spread lets us see how much data varies. Range is a quick way to get an idea of spread. It takes longer to find the IQR, but it sometimes gives us more useful information about spread.
Yeah, so basically range hasn't changed in their definition, right? Wise, right? Take max, take the highest number and subtract it from the lowest number, right? And you could go ahead and at least get an idea of, well, if somebody's like way off, that's now you're talking about somebody like giving you something really, really different. Okay, now let's go ahead and move on. Let's talk about these two right here. All right, so it says find the IQR in the range. So how would I find the IQR in the range? Any ideas?
Find the IQR in range? Oh, so the IQR would be, you just have to take the first quartile and the third quartile.
Exactly. Yeah. So I take 23, and that looks to be actually 16.5. Yeah. So this is Q3, and this is Q1. We subtract those. We get what is it? 6.5.
6.5. Yeah, 6.5.
And then what about the range?
That would be the maximum minus minimum, which is 27 and 13.
Mm-hmm.
Yes. So that will be then 14.
14.
Yeah, so there's a 14 difference altogether. And this one had to do actually with volunteer service hours. So one thing that I'm able to tell you is that for the most part, most people are doing 20 hours, but there is a range of about 6.5 hours that changes not from there, but just that from 20, either people are popping to 16.5 on average, or they're doing about 23 in this case. Okay, so that's where most of them are doing that.
Wait, buddy, why did you do Q3 rather than Q2?
Because technically, Mama, Q2 is median. That's how they call the quartile range. Like this is the first quartile, because remember, this is 0, right? So then they, in what they do is that they call this is kind of like Q0, Q1, Q2, Q3, Q4. And this is how they come up with the number. But they don't call this Q2 because it's best known as a median. But when they were trying to figure out a name for it, they just said, well, let's call it Q1 because we don't teach it's not like, it's the best name they came up for it to make sense with the graph. All right, but good question. All right, good. Okay, so apart from that, write down the notes. Glad everybody joined us today. And then, and everybody go ahead and say bye. Bye. Bye,
Bye.
everybody.